Thank you. Yeah, as Usui Sensei introduced me, I'm Mark. I'm a PhD student right now, first year. I will be second year from next week, so D2. At Monase Laboratory, we do computer vision stuff mostly, or multimedia analysis. And yes, I'm a PhD student. I'm not a PhD student of leading, like not of RWDC, but separate. But I'm doing research assistant in this program, so I'm in charge of English translations and stuff like this. So yes, the slides, my talk will be in English. If there are any questions, Japanese questions are also okay, I guess, but let's keep it in English for first. My topic is Python. Python is a programming language. And the reason I talk about Python is that's an incredibly popular programming language, especially since the last couple of years. Python has, I'm not sure, like Python's probably there for like 15, 20 years, but especially in the recent years, like maybe the last 4 or 5 years, it got really, really big. At the moment, this data from 2016, and well, Python almost has a 50% share in programming languages, above everything else, like even Java and C++, etc. I think this data is programming languages in a computer science sense, like doing apps, doing stuff like that. I found a second statistic for data sciences. So that's basically not only computer science, but well, anybody who does something with data, like biology, physics, economy, stuff like that. So any kind of field where data is used and data processing is very popular. There's basically 2 languages which are very big at the moment. One is Python, and the second one it's called R. So both of them are very big. Until last year, basically, R has been a little bit bigger, but even now Python got more popular. So whether it's computer science or data science, basically Python would be the way to go, especially for the future, I think. So it's a very important language when you do stuff with, well, data processing and data science. So what is Python? Basically, Python is a general purpose programming language. Same as, I think yesterday you had Java, something like that. It's a scripting language. It's open source, so it's completely freely available. It has a very incredibly large and comprehensive library. And not only a library, but also extra packages. So you can basically download anything, and it's available for Python as an extra package or something like that. In its design, it's kind of made to be very readable. So you can quickly grasp a code. You look at code and you quickly, you're supposed to quickly understand what it means. And you can do very quick prototyping. So a lot of other languages, like you need to set up a project and you need to set up some classes, etc., etc. It takes time. Whereas Python, you have 3 lines of code, and you can do something with that. It works. You can do some math. You can do all kinds of calculations with very short code, with a very short script. So that's one of the things. And there's automatic memory management, which if you're not computer science, you probably don't even need to know. So there's one bad thing with Python, which makes working with Python a little bit weird sometimes. There's 2 different versions. There's Python 2 and Python 3. At the moment, it's 2.7 and 3.6. And they are not really 100% compatible to each other. So if you have like very old code, it might not run on the newer version. And if you have very new code, it might not run on older versions. Right now, Python 3 is winning. So everything new is kind of in Python 3. So this lecture will also use Python 3. But just so you heard of it. If for some reason, if you ever use Python and something doesn't work, it might be this. It might be an old version. So let's first talk a little bit about the appearance. Python looks very different than many other programming languages. Yesterday you had Java, I think. So Java looks a little bit like this. This is also the syntax of something like C or C++. So you have all these kind of brackets, which kind of says how the code works. Like the if is defined by the bracket and stuff. If this is true, something inside the bracket works. Something inside the bracket runs or executes. Python works a little bit different. It uses this kind of white spacing syntax, or indentation. So we have code like this. These are two examples. First look at the left one. So x is 0, y is 0. If x is 10, we set these values. So x would be still 0, and y would be 10. So looking at this code, both are 0. If x is 10, we change something, but x is not 10, x is 0. So nothing happens. Both of these are inline, so nothing happens here. And this prints 0, 0. On the other hand, if we do something like this, and just forget these two spaces here, like this is just moved to the side, suddenly it changes everything. So x is 0, y is 0, okay. If x is 10, x is changed, but then y is changed anyhow. It's not moved here. So it basically is once just like these lines. And now it wouldn't be 0, 0 anymore, but it would be x would be 0 and y would be 10 because it changed anyhow, even though like this is not part of this if statement anymore. So this is just a small example, but it kind of shows Python works a little bit different than many other programming languages. You really need to always keep in mind how to do this spacing. That's a very unique thing. I think there's not really another language which does that. Maybe there probably is one, but not a bit one. So if you look at all the popular ones, Python only does this. So another thing which is a little bit different in Python, it's a scripting language. So something like Java, you have like your full app, you have like the big .java file, you put in all your code, and then you run it through a compiler, and then you have your app, and you can run your app. Python doesn't do that. It's a scripting language, so there's multiple ways to run that. One would be even like in a terminal. There's a small example down here. So you could just run Python as a command on your command line, and then there's like this interactive thingy. So you're in this terminal thingy, and then you could like your a is equal to 10, b is equal to 20, and then you put a plus b, and Python calculates it for you. So that's 30. The output is 30. So it's like it works in this interactive mode. You don't even need to have like a full app. You can just work like this. Of course, you can also do a full app. Like that would be the same thing, just in the proper way, like as a script. It's basically the same code. A is 10, b is 20, print a plus b, and then you can run it on the command line. Like this would be an editor. You put it into a sample.py, and then you can just run it, and it puts your 30. So whether you do it like this as a inside the terminal, like interactive mode, or as a script, it's basically your thing. We do both afterwards. Like I quickly talk about some backgrounds, and then I have some code examples we go through together. We do both. There's lots of other ways. There's like a web UI. It's called Jupyter. Basically, you get like this kind of web-ish interface, and you can run it in your browser. That's often used if you do something remotely, like on a server or something like that. There's also lots of other ways. Like there's IDEs. Out of these, probably the biggest one would be PyCharm. It's basically like a full environment. It's like Visual Studio, or I think Android Studio might have used yesterday, maybe. So there's also stuff like that, but you don't need it. You can just use scripts like on the slide before. So now I quickly want to talk about why Python is actually so much used. Like Python is On the first slide, I said 50% of people use Python at the moment. Why is that? It's mainly extra packages. So there's this website called PyPy, and it has anything. Like you can have extra packages. It looks like this. I didn't put a link. I think it's pypy.com or something like that, or maybe .org. You can basically this is an example, sklearn, that's a very popular library for machine learning, but it has everything, like machine learning, text processing, image processing. The next lecture, OpenCV, will use an image processing package using called OpenCV. That's also a Python package. There's thousands of packages available for Python, and basically whatever you need, whatever you want, it's probably already implemented as a package. So you never really need to do something yourself. You just need to find the right package, and the package does it for you. At least when it comes to algorithms, which already exist. So there's an built-in command called pip, which can install these kind of packages. There's also Anaconda, which we use here. It's already pre-installed on your laptops. I will talk about that a little bit later. But basically using this, stuff like that is available. So for scientific computing, there's different libraries, numerical computing, deep learning, machine learning. This one is for SVNs, clustering algorithms, k-means neighbors, stuff like that. Like all kinds of different algorithms are already pre-implemented in these kind of packages. So whatever you need, just find the right package, and you can probably do it. And all these packages are available on this website. So that's one of the reasons Python is very much used. The slide before talked about Anaconda. That's a very neat little package. It's basically a one-click installer for Python and everything else. So you have Python, you have hundreds of packages. I think almost everything on the slide is pre-installed. OpenCV not, maybe the deep learning stuff not, I'm not sure, but everything else is pre-installed. So Anaconda is like a one-click installer. It's available Windows, Mac, Linux, whatever you're using. You can install it with you can download it on anaconda.com, install it, and everything is installed in one go. They have a version for Python 3, they have a version for Python 2, both is available. Just install it wherever you need it. On all these computers, it's already pre-installed. We installed it for you 2 days ago. Feel free to try it at home or on your lab computer. You will probably need it. We do a first small example. Like I said before, there's these hundreds of packages available for Python. How to install one of these packages. The next lecture, directly after this, David will present about OpenCV. So we need OpenCV installed on all these computers, but we didn't do that yet on purpose. So one way to install OpenCV would be to go to anaconda.org. There's this field. You can just type in OpenCV, and then probably the first one in the top will be this, mempo/OpenCV3. And if you click on it, this page comes. And here it says basically how you install this. So you need to go to the command line and write conda space install space -c space mempo space OpenCV3. So I would like you to do that quickly, because you need it later on. And just as to get familiar with this packaging system thingy. Yes. So basically, if you go to this website, search for it, you can just copy-paste this, maybe, and put it to the terminal. Yeah. I can quickly show it here too. No, not come. Good that my internet is not working. That's good. At the moment I use my hotspot, which doesn't seem to connect, but I also don't have anything else. So, I use Unit, but that also doesn't connect. So now it uses my hotspot. This is this cloud website. Just put in OpenCV, and basically it shows you everything available. So there's lots of packages called OpenCV something. We want this at the top, which is also the most downloaded one. So usually, if you have lots of different options, take the one which is most downloaded because that's probably the right one. So clicking here on OpenCV 3 gives you this page, which basically gives you some details. So for example, it tells you like which version for which operating system. Sometimes like Linux gets a different one than Windows. So this is the command basically. So copy it. And then you can go to the terminal. And there's a C missing. Just like this. And then it should install. Which might take a minute or so. Hopefully. Okay. On my computer is already installed. On your computers, probably it will ask you whether you should install it or not. But no, it says failed because I already installed it. I don't know. I don't need it anyhow. Okay. So in future, basically this is one of these examples. So you can put anything here. For example, sklearn, which is a machine learning. There's different things here. If you need something like Theano, which is numerical math, I guess, it's available. So whenever you need something, you can install it like this. For example, click just here, and then it will give you such kind of link, one of these, probably the upper one. So yes, just as an example. So I will quickly go back to the slides. So yeah, the package which is now installed for all of you, David will talk more about that later. So please use the same computer, but probably you will. So that's basically one of the things why everybody loves Python. You have these millions of packages, you can just install them with this. There's another thing which people really like about Python, and that's the documentary, like the documentation. That's a really good documentation, like docs.python.jp, for example. It's even available in Japanese. So it explains everything. You can read it. It explains all features of the language. It's also available in English for your Chinese students, or like it's probably available in Chinese too. Just find it in your language. It explains everything about. I can quickly show. I think I have it even open. Yes. So this is just an example for data structures. So this one, listo, is basically the in Python's list. It's basically the class for arrays, stuff like that. So it basically explains everything. It tells you how to use these different functions. It tells you which functions are available. It gives you some examples how to use this stuff. It's really helpful. And as you see, it's a pretty long page. And that's just for arrays. So whatever you need, there's basically a full tutorial over here. And it does everything. So it does like how does if work, how does for work, all kinds of different functions. Yes. And this one is a Japanese one, but I mean Python, docs, English. That one would be the official English one, which is probably more up to date. I'm not sure. Here, docs, Python 3 docs. it basically explains everything. So yeah, very deep. And let's see, Python 3 docs Chinese. Yeah, there's something available here. So Korean, do we have Koreans? I don't know. Korean probably too. So yes, this is one example. The next slide is basically other examples. I don't make it big right now. Just the thing is, Python itself has all kinds of documentations. All these libraries, like the one we just installed, OpenCV, but there's other ones like sklearn, NumPy. All of them have libraries too, and they are great. So NumPy is a very big one, which is used for math. Yeah, like this, you can find everything. Like how does arrays work in NumPy? How does different functions work? Whenever you have trouble with programming, one of this will help. Usually there's also a search function somewhere, I don't know where. But yeah, or sklearn here, for example, it gives you an overview of all different functions. So there's different clustering algorithms, different estimators, data sets available. All of this is pre-installed. So all these data sets here, you can just use them in your code. And if you want to know how k-means clustering works, you click on k-means clustering, and there's explanations and probably even an example somewhere. Yeah, here's even an example. So yeah, stuff like that make Python Python. So that's basically the reason people use Python so much, because it's really great to have this, and other languages usually don't. So that's very, very, very valuable. There's also Stack Overflow. I think David talked about it in the morning session. If everything doesn't work, Stack Overflow probably helps, or Stack Exchange, it's the same. So yes. So that's a very short introduction about Python, what makes Python great, and yeah, why you should use Python, why it's such a good idea to have it in our classes. So yeah, that's basically the theoretical part-ish. From now on, I'd like to have some more code examples. So I don't know if there's any questions until now, but if not, I would probably jump into the smaller examples. So basically, I think all of you have still the terminal open where you put in the conda command. If you just put Python like this, how do I do this? Probably just show my terminal also. So can I make this bigger? Open profiles. No, that's not the right one. Edit. Text. Change font. How big can we go? Well, that looks good. So if you put Python, it should kind of look like this. And that's now the kind of interactive thingy. So the example earlier was something like this. You put A is 10, and B would be like 50, and A plus. Where's plus? My keyboard. Maybe I should use German. Plus. So A is 10, B is 50, A plus B is 60. Makes sense. A times B would be 500. Also makes sense. So that's very short examples to directly work on this command line. So basically, one example I want to show you is for loops. I'm sure you probably had something similar in Java or maybe in the shell scripts from David, I'm not sure. But the idea is to make this loop which prints numbers. So that's a very simple example. So for I in range, let's make 10. So that's a small loop for every number I in the range 10. So 10 would be, I just use this range 10 function. That's basically, it means, I hate this keyboard. It means something like this. So it's very low. So basically, range 10 means first a 0, then a 1, then a 2, then a 3, etc. From, so basically 10 numbers. That's why 10. Shouldn't it also work like this? No, it doesn't. You could also have something, of course, range 20 would be all numbers from 0 to 19. Or you could also have something like from range 10 to 20. That would be 10, 11, 13, 20, until 20. So yeah, that's a function. And this would be a for loop basically for every number in this. So this is basically all numbers from 0 to 9. It just prints this number. So it first prints a 0, then it prints a 1, then it prints a 2, 3, 4, 5, 6, etc. So please try out this example. Yes. Okay. Looks. I think everybody figured it out by now. As I had this example up here, you can make it like this. So for example, you could put like, let's say from 15 to 30. And then print that range. And from 15 to 30, it always means, well, the numbers in between, but it excludes the last one. So it's, because it starts with 15, so it's 15 numbers, including the 15, excluding the 30. Yeah, you can put whatever you want. It just changes what it will display. So that's one example. The next one, this is a little bit more interesting. Well, not really. It's kind of a loop in a loop. So basically, what we did before is we have this for I range, and then the print inside, which just prints this I all the time, like 10 times or something like that. You can make this big. You can also put another for into it. So you could put for j, and then you have two different numbers to display. So you have like an inner I, an outer I, an inner j, and if you then print it like this, print, comma, you don't need that in the middle. You can also just make an example here. So you have like let's print 3, and then for j in range. Here you maybe want 5. The spaces are important. So this one, the I goes from 0, 1, 2, and the j goes from 0, 1, 2, 3, 4. So 3 different numbers for I, 5 different numbers for j, and just print both of them. So it would, first I is 0, this one is 0, then it would print all j's, so 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. Then I is incremented once, and then it prints all j's for that, etc. So that's called nested loop, because there's a for loop inside a for loop. So 2 different loops are running, which is kind of helpful for a lot of things. For example, if you have something 2-dimensional and you have values inside something else, then you could loop through the values like this. Quickly want to try out that one, maybe. Keep in mind all these spaces. Every level needs more spaces than the level before, because the idea, for example, is this one would print like before, but if you go back to this level and have another print I here, you could have like this one is printed 5 times for all these 5 4s. But this one is only printed 3 times, only for these i's. So you have 5 times this, which is this, but only 1 times this, because this one is put back to the same level. That's the idea with Python. Like you always need to put these spaces into keep attention of these. Okay, seems everybody finished that one, which leads us to the next one, which is almost the same but a little bit different. So before that, we always had this range command. Just means, okay, we have these numbers between 2 different, like from 0 to 1, from 0 to 10, or from 0 to 20, or something like that. There's a different thing you can use a for over, and that's basically lists. That's literally the list which we had in this Japanese tutorial screenshot a couple of slides ago. So that's how an array looked like. So you could make an array. Colors is equal to, okay, we have red, we have green, blue, yellow, we have different colors. And using these brackets around them makes it to a list. So that basically makes them arrays. So we could define, we have colors. And colors would be red, blue, yellow. And I don't type all of them because it's too long. So now this creates an array with 3 elements. An element called red, an element called blue, and an element called yellow. 3 elements in an array. So having that one, we could again have a for loop over these elements. So for every, I use I again, but you can use any letter. For every I in colors, now it's not in range because we don't go over 1, 2, 3, but we want to go over red, blue, yellow. So for every element in this list, and now we can just print it again maybe. So yeah, it takes the first element, prints it, takes the second element, prints it, takes the third element, print it. Yes. Maybe try that out a little bit quickly. Yes. Maybe I can put my example if you want to copy it over. Okay, but I think, yeah, okay, if you have the same computer, just start the terminal and open Python again. There's a second example for this, which just goes a little bit more complex with this enumerate function. So here we have 3 different colors. And now I is the color. So we don't really have the number anymore. But sometimes we still want to have a number. Like we want to maybe just for printing them, so you know this is the 50th iteration, something like that, or for logging purposes or for something else, often it is handy to have a number, even if you want to use every single element in this list. So for that, this is what is it called? Enumerate function. And now you could have two elements. I think this is right. Let me quickly check that. Yes. So using this enumerate function, then you can get 2 back. Here it's 4e in colors. We only have I. We only have this one element for every 4. But when we use this enumerate function, we suddenly have 2. So the first one would be the number, and the second one would be the color. So when we print it, we don't get red, blue, yellow anymore. We get 0 red, 1 blue, 2 yellow. So we have these numbers again. We know how many it is. And of course, for 3 elements, it's not that interesting. But let's say you have 10,000 elements, then it might be interesting that you have the 800th one and not the 900th one or something like that if you use data processing. Because afterwards, we go over a very large data set with maybe thousands of elements. So then it's maybe handy to have real numbers instead of all these names. Because who knows whether red was the first one or the second one or the zeros. But if you have the numbers, it helps. So how much is it time? Time should be okay. So if you want to play around with this example, in the real slides, by the way, you can also make this a little bit more beautiful, like putting text in between these, something like that, if you want nice output. But that's not really scientific, I guess. But yeah. Another example done. Now, after this, we look a little bit into NumPy, which is basically a math library, which is kind of important for lots of math-related stuff. It's basically used by almost every other library. So if you use OpenCV, like in the next lecture, or I think sklearn, or maybe other ones, like almost everything in Python which is related to data science uses NumPy in the background for calculations. So I think the reason why it is used is because NumPy provides you with very nice functions for arrays, which is basically matrices in math. So for example, this is a way to declare something like, what is it? Is it that one? Or is it? I'm not sure which one of the two, David? How? That example of a matrix, which one is it? Should be this one.
I can never remember. I think it's the second one.
That's probably the second one. But yeah, I mean.
If you've done MATLAB,
MATLAB is.
You did MATLAB yesterday, right? It's completely different. So
Yeah. But one way or another, I mean, that's another way. If you really need it, just look it up once again in the documentation, and you can read around about all functions. But the idea is basically to give a handy way to implement matrices. So you have this syntax, the second one. So you have this syntax for this kind of matrix. I mean, you could also, if you put another like comma, here, comma, and then like 6, 7, 8, you could have like the 6, 7, 8, have a bigger matrix. It's kind of, it doesn't need to be 2D or 3D, it can be multidimensional. You can do whatever you want. It's basically just a framework. So to use NumPy, because NumPy is not Python anymore, it's a library, it's a package, which is already pre-installed because you have this Anaconda thingy. If you don't have Anaconda, it's not pre-installed. That's why you should use Anaconda. But so because it's a package, you need to import it. Import NumPy as np. So now np is like, it's called namespace, you don't really need to know that, but np dot something basically is stuff inside this np library. So you could make a new matrix. Why do we name it A? We could make it M for matrix, and then np array. Yeah, 1, 2, 3, 3, 4, 5, 6, 7, 8. What that? To keyword. Okay, that function only. That I have not understood. np array. Okay. 1 is missing. Around here. Yes. So that would be this array. Yeah, okay. If you print it like this, it even shows you. So this would be the first example. Or if we make it longer, 6, 7, 8, M. Yeah. So this is a way to have this mathematical matrix defined inside Python code. So here it's called an array, but basically you get this kind of data structure. And yeah, I should have looked into the slides because it actually tells you in the next one what do you do if you want to turn it. So you can use np reshape and reshape it. Does it work with v3? This is the syntax. No, it doesn't work because it's already 3.3. It was a bad example. Yeah. If we use it like this, yeah. So we can make from as a pen. This one we can define with this m equals np.array, and then just typing it like this would make the white one. And then we can like swap it around. What's the right mathematical word for that? In NumPy it's called reshape, to make it into the. No, wait, 1, 2. Oh no, yeah, that's a later step. It literally reshapes it like this. This. So it would be 1, 2. I think the other one is the next example. What is it called? Transform? No, it's on the next slide, I think. Yeah, but bad examples over bad examples. But basically, the idea is this library helps you with all kinds of matrix stuff. So whenever you have like multi-dimensional stuff, this library kind of does anything. It can even do like 1,000-dimensional, 1,000 times 1,000. Too big to calculate on the paper, but NumPy can do it easily. So if you want to play around with this a little bit, I don't know, have you? Yeah. Okay, anybody seem to more or less played around with that? So, here's the other one. So, yeah. What's that be? First element 3. Yeah. So the last example just shows you how to change something. So let's go with this last one. We have, what's that? Japanese keyword? German. we have this M. So let's say we have one, two, three, 1, no, 0, 1, 2, 3, 4, 5. We have this matrix, and now we want to change a number. So let's say, which is this 2 should be an 8. So how do we do that? It's basically the syntax. So M, and this is the new syntax. So this basically means inside M. So what's the right order? Inside M, the 0th element, I think that's right, which would be the first line. And then out of that, the second, I think. Well, the third element, which is counting from 0, is 0, 1, 2. So the that element, that one, we want to make to an 8. Yeah. So starting from this matrix, in the first line, the third element should be an 8. And now it is. So now it's an 8 instead of a 2. What he just did, but it's a good example actually. This one assigns an 8 to this value. Sometimes, especially if you have a very big, if you do this, it prints the full array, the full matrix, which is 2 lines and 3 elements. It's okay for the screen, but let's say it's very big, then it wouldn't fit on the screen, and you're in trouble because you can't really print it. But you can use the same syntax. Where is it? Without this, we leave out this and just put it like this. And it gives you that element. So it's a way to look up which number is in this slot. So we want this 8. Okay, the first line, the third element. If we want the second line and the second element, that should be a 4. Yes, it is. This 4. That's a way to look up elements. So, and again, if you use the same command and now equal, we can set it to something new. So let's put it to 10. Now that element, which was a 4 here, now it changed to 10. So, yes, just another hint on how to use this. So, going to the next slide, and I think we are very soon done with this NumPy examples, and afterwards I'll just show you very quickly some longer in-depth stuff. But then you don't need to type everything, and you don't need to follow through because it's very long scripts. Here's a couple of other, do we really need to go through all of them? Basically, there's these other functions, for example, arange, hstack, vstack. It's a nice thing again, as I said earlier, whenever you don't really know what this means, like we have hstack, and suddenly you're in the middle of a lecture like me, and I don't know what it means, just as an example. I could just Google it. And this one is the documentation by NumPy themselves. And luckily, they have an explanation. So this one, for example, it stacks arrays in sequence horizontally. So they even have an example. That makes this a little bit bigger. If you have one array, which is 1, 2, 3, second array, which is 2, 3, 4, and you use an H stack on both of these, they're put after another. So 1, 2, 3, 4, 1, 2, 3, 2, 3, 4. 1, 2, 3, 2, 3, 4. So they're put one after another. And vstack basically does the same, just vertically. So let's say we have an A, 1, 2, 3. We have an B, 6, 7, 8. And what was the syntax? np hstack ab. This one puts them directly after each other. So we have this 1, 2, 3. We have 6, 7, 8, and this one is 1, 2, 3, 6, 7, 8, and 1. And the same with vstack. Would put them, well, horizontally, so in 2 lines. Of course, the result of this, you could put it to C, and now it's in C, and you can use it for some next calculations, for example. Yes. There's also a range. Returns an evenly spaced values between a given interval. So basically, a range is the range function from Python just for matrices. So before we had these for e in range 3. In the beginning, this is basically a range from 0 to 2. You can do the same with numpy.arange for matrices. So, yeah, if you want that, you can make a matrix out of that. So, I think we don't need to do it like everybody themselves, I think. But hearing of these functions, like just as an example, what exists, like you can go to this array creation routines, and basically it tells you what exists. So there's like a function which creates a matrix full of zeros, or a matrix full of ones, or the identity matrix, or just an empty one, or all kinds of different ones. So it's all kinds of different ways to work with different matrices. On the next slide, can I copy paste this? Of course not. Yeah, probably I should. So that's until 11. So mp away. From 0, yeah. Okay, so let's assume we have this a little bit bigger. So this one is 3 times 4, a little bit bigger matrix. I mean, I don't really need to write it. It's basically as a mathematical matrix like this. And now, for example, we want just the first 2. So we have this big matrix and just want to get the smaller matrix out of it, the first 2 lines. So that's an example, D02. Basically, this is a very special syntax, which I think also only Python has. But the idea is that would be the first 2 lines, and this colon means the full line. You can also reverse it, which basically is the first 2 columns. So now it's the full lines, but only the first 2 columns. This is only like the first 2 lines, but the full lines, this is the first 2 columns and the full columns. So depending on the order, you can play around and extract only part of this element. So this is the full matrix, like 3 times 4, And using this, you can, for example, only take the first 2 lines, or using this, you can only take 2 columns and throw away the 3rd column. So little stuff like this is basically data manipulation, getting parts of your data if you have bigger matrices. Yeah, and it goes on, of course, if you have these matrices and you have math, you probably want to do math with the matrices. It just works standard math. So plus works, minus works, multiplication works. You can just use your standard, so something like a times a3, a plus. This one is obviously 8. The same also works with away. Plus and pay away. So it adds 2 matrices to another. And the same works with minus or, yeah. So you have your standard arithmetic operations on top of your matrices. There's cross product, there's dot product, there's all the stuff, there's predefined functions. I don't know, like, yeah, for example, here's 2 examples. I quickly just go over them without typing them, but for example, T, that's the one I was looking for earlier. So if you have this and you want to swap it with just b dot t, big T, then it is this, you have that one. And then, for example, you can make a dot product with dot a dot dot and then brackets and then the other one. So that's a dot product between A and C. And you can have the same if you use cross, then you have a cross product between A and C and all kinds of other stuff. So that was a very short introduction to NumPy. We have another 15-ish minutes. Basically now really the practical part is done-ish, but I have a couple of larger applications where I just want to show you a couple of other Python scripts, a little bit hands-on, just to show what's possible, kind of. If you want to follow along or play around with it, there's this link, which is to my Dropbox, and all the scripts I'm using, it's I think 3 different scripts, are in this Dropbox, if you want to follow along. Yeah, so if you put this into your browser, then you can access the files if you want. If not, does anybody? You can just go ahead if anybody wants to copy this link later, tell me. The first example goes into scikit-learn, which in short is sklearn, which I already talked a couple of times about. It's a very big machine learning library, and for example, me in my research, I use it every day, so it's very important for me. Like, we have clustering algorithms, classification, regression, all kinds of stuff related to machine learning. Dimensionality reduction, you have stuff like PCA, you have all kinds of, basically everything pre-implemented. So whenever you need anything, like any clustering, PCA, similar stuff, it's implemented, it's one code, and you have your full algorithm, and you don't need to think about it. In Connor, you can install it like this. I think it's even pre-installed. I think on all these computers it's already pre-installed. So if it wouldn't be, just search for scikit-learn, then you get it. Just as an example, what does it have? Regression algorithms like Lasso, ElasticNet, Ridge regression, SVRs, You have different classification or clustering algorithms like k-means, mean shift, spectral clustering, kernel approximations, naive Bayes. You basically have anything you want. Everything is kind of pre-installed, and all of them have more or less the same API. So if you know to use one of them, you basically know to use all of them. And it also has pre-installed data sets. So there's one data set, these slides use as an example, is related to these flowers. Yeah, I'm not biology myself. I have no clue about that. But I think it's different species with like the size of the petals and yeah, different values for that. So it's a very big data set, which is used in biology, I think. And just as a basis, just as an example, this would be pre-installed on sklearn. So you can you have, I think it's on the next slide somewhere. Yeah, you have like, there's a function load iris. And then you can just use it to have the full data set. And I think here sklearn, no, not that one. So here they even have an overview which data sets are implemented into this library. So yeah, lots. All these different data sets, diabetes, digits. It's usually example data, of course, for your own research. You maybe use something else, but you can use it to play around with the library. So the first example kind of just uses this. It gets from sklearn, scikit-learn, it uses this data set and basically just arranges a small part of the data using pandas. Pandas is another library. And just prints it out to show some insight on the data set. It's called data check. And I think I have it. iris data check. Martisan, yeah. Of course. So now, as I said earlier in the slides, of course, you can have an editor and just create a .py file and just put all your code inside that, and you don't need to put it every time you want to use it. But this works basically the same as the terminal you tried in previous examples. So all the code, no, that one, all the code from the slides. We first load the data set, put it into some kind of data framework, and then just the data is printed to show how the data set looks like. So if you put it on the terminal, you kind of get knowledge like this is the data set. Like for different data samples, you have like a length of the petals. It's this data set. So basically, I think it's even the same values. So the length would, for the first sample would be length 1.4, the width is 3.5, etc., and you have different species. And this is just printed, like the different values on the terminal using this script from the slides. It just prints the output like directly loaded. As one example to get this, to use this library to analyze data. As a second example, which goes a little bit further, it's called visualization. And now we, want to visualize this data. So we still go ahead. Can I make this bigger? The data set is loaded. Matplotlib, that's the plotting library, it's also loaded. And then we get our features. Like we get some data from the data set, we get the names, we plot it to a figure, and then basically it's a scatter plot is made. Like a graph, like a scatter plot is like you try to plot stuff, data points into a plot to see how it's scattered over the Euclidean space, basically. So as a spatial plot. So and using this visualization, it should, if it doesn't hang, here. Why doesn't it come? No. So this would kind of plot these data samples. So that's the length. No, all of them. Yeah, these are the lengths. This is the petal width. Another. I think that's. I'm not sure how it's set up. I think it's for the different species, something like that. So basically, yeah, you iterate over the different combinations of species and then try to plot it into a graphically nice-looking plot. So here we use two different libraries. One is sklearn, which just provides the data, nothing else. And the second one is matplotlib, which is a plotting library, which is pretty hard to use. Like, have fun looking that up yourself. You probably need to copy-paste tutorials because I use it since 6 years now and I still can't really. It's kind of weird to use, but you find lots of examples online. Just Google what you want to plot, and then you find an example for that. And yeah, you can make nice little graphs like the one I showed before. Here's it again. And the last example is a classification example. So again, we load the data set, we get the features of the data set, and well, the labelings. And then we split the data set into a training set and a test set, and basically train a classifier on top of that. So these classifiers, here's it's an unspecified classifier called classifier. Usually you wouldn't use a class classifier, but you use something like a special one, like you have this slide. Like there's kernel estimation, there's k-neighbors classifier, there's SGD classifier, linear SCV. You pick the one you want to use for your research or for your problem, and then load your data set, fit the training data and the labels into the classifier, which one it is, and then predict the results. And this function, this short script basically does exactly that. It predicts some results and outputs a confusion matrix and the F-scores and the accuracy of that classifier. So Dropbox. Looking into that one again. Python. Basically, it's trained a small classifier and yeah, gives us a very good accuracy in that example. If I run it multiple times, it should change because the test set and the training data changes every time because it's randomized. This one creates randomized test data. But yeah, so for example, in this case, it gives us a confusion matrix from this classifier. It gives us the F-scores, so the precision recall F-score support, and gives us the overall accuracy of this classifier. So in that case, it could classify the data with 93.3%, which is pretty good, I guess. But yeah, so this is an example of what you can do. And sklearn is very straightforward for that. So if you have a small example like this, basically you can do whatever you want. Like changing the classifier is just a thing by changing the name. Because this fit, this predict, all these other functions, they're always called the same. So if you have one example, just change the name and you can change the algorithm. If you want to use it, basically, again, looking into the documentations, usually, let's say, okay, we had a classifier as an example. So, for example, here we have different classifiers. So, usually it tells you like which functions are available. There's like a predict function. This is fit function. So that's the one we would also use here. Fitting data, predicting data. And usually in the bottom there's even like such kind of examples. So for example here you find the code just comparing 10 different classifiers with another or other ones. So yeah, what you should take away from these couple of short examples is basically use the documentation a lot. Everything is documented. Find such small examples like that one. Start with such an example and then go on from that. Play around with these parameters. Change the classifiers. But as you probably get from this is less than 40 lines. And it can already train a classifier and get you the results, which is pretty short compared to something like Java, which you have 3 times of that and probably no results yet. Which makes Python such a great language for prototyping smaller things. So yeah, with that, we are exactly on time, and my last slide is done. So I would be done if anybody has some questions about Python or anything else. Otherwise, I'm done and would. Yeah, I'm done. So, what should I say? Is there any other questions, or otherwise, yeah, I guess it's break until David's blog in 30 minutes.